Welcome to Study Loop.
So we are told that a block of copper at 20 degrees Celsius is placed in water at 80 degrees Celsius. And we are asked to calculate the entropy change of the copper, the water, and then the entire universe. And so an important approximation firstly is that the water nor the copper change appreciably in temperature after the small amount of heat flow of 1 joule. And this is important because the formula for the change in entropy, Q over T, is only valid at constant temperature. And so we make the approximation that the temperature is approximately constant during this process. And so to calculate the change in entropy of the copper, it is simply Q over T, where Q is the amount of heat flow, and T is the temperature of the copper. So we are told that 1 joule of heat flows over the temperature of the copper, which is 20 degrees Celsius, but we have to convert this to the absolute temperature scale, and so 293 Kelvin. Now, we also need to make sure that we put the right sign before Q. And in this case, the heat will spontaneously flow from the water to the copper piece because it is at a higher temperature. And so we leave a positive sign here to indicate that heat is flowing into the copper. And so we obtain a result of 3.41 times 10 to the minus 3 joules per Kelvin. And so we can do the exact same process for the water, where now in this case the same amount of heat flows, 1 joule, but it is flowing out of the water, indicated by a negative sign, so out of water, over the temperature of the water, which we convert to kelvins, 353 Kelvin, for a result of negative 2.83 times 10 to the minus 3 joules per Kelvin. And lastly, the change in entropy of the universe is simply the sum of these two changes in entropy. So the change in entropy of the copper plus the change in entropy of the water. And so 3.41 times 10 to the minus 3 joules per Kelvin plus negative 2.83 times 10 to the minus 3 joules per Kelvin, for a final result of 5.8 times 10 to the minus 4 joules per Kelvin as the total change in entropy of the universe. If you calculate the change in entropy of the universe and you get a negative answer, then you know that you've done something wrong.